Hi, welcome to Ignited Minds. The sole mission of this is to encourage constant learning by sharing knowledge and experiences in the form of videos and lectures. Please subscribe to this channel. In this video, we're going to tackle an exciting problem related to triangles and angles. So, the problem is prove that a triangle must have at least two acute angles. Before we go and figure this out, let us a quick recap about what exactly mean by acute angle and obtuse angle and right angle in a given triangle. So an acute angle is an angle that measures between 0 to 90 degrees. Some of the examples include 60 degrees, 30 degrees, 45 degrees, etc. And coming to right angle triangle, it is an angle that measures exactly 90 degrees. In fact, as a right angle, you can easily observe, because it forms like a shape of a letter L. And coming to obtuse angle, when the angle measures greater than 90 degrees but less than 180 degrees, it is called obtuse angle. So, given that we have reviewed these definitions, uh, to basically prove that a triangle must have at least two acute angles, let us consider all the possible combinations and let us go through those combinations and prove which of the combinations are not possible and which of the combinations are possible for a triangle, and accordingly we can prove the given problem. So when you look at it, there are actually four cases that are possible for a triangle. Let us review each one of them and see whether they are really possible or not possible. Case one, two angles of a triangle are obtuse angles, and the other third angle could be any angle, could be obtuse, right angle, or acute angle. Similarly, case two is two angles of a triangle are right angles, and the third angle could be any other angle. And the third case, where we have one obtuse angle, one right angle, and the third angle could be any other angle. Similarly, the case 4, where we have two acute angles and the third angle could be anything. So let us take each case and see whether they are really possible or not. So coming to the case 1, where two angles are obtuse, and the third angle could be either obtuse, right angle, or acute angle. So suppose let us take two angles of a triangle. Let's say A and B. Let's say they both are obtuse angles, which means both are more than 90. So when you really sum up the A and B, the angle A plus angle B, says A is more than 90 and B is also more than 90. So what do you get? Well, if you sum it up, the result will be more than 180 degrees, right? And going by the angle sum property of a triangle, the sum of all the angles in a triangle is 180. So what we have is A plus B plus C, the angle A plus angle B plus angle C is equal 180. So let us substitute whatever we derived above into this equation. So when you put angle C equal to 180 minus A plus B, right? We are trying to see whether angle C is possible or not. Now that we already deduced from the above that the sum of angle A and angle B are more than 180, let us substitute that here. So when you substitute that here, as you can see from this equation, what do you think will be the value of angle C? Well, the angle C will be negative in this case, right? Because 180 minus anything more than 180 obviously will result in a negative number. So angle C is a negative angle, which is obviously not possible. So there's no triangle possible with this case 1. So we'll rule out this combination. So hope you're following this. So let us go to this case number 2. In case number 2, two angles are right angles, and the third angle could be obtuse or right angle or acute angle. Let us again assume that angle A and B are right angles, so that means both are equal to 90 degrees. So since both are equal to 90 degrees, when you do a sum of angle A and angle B, which is nothing but 90 plus 90, which is equal to 180 degrees. Again, going by the angle sum property of a triangle, wherein the sum of the angles of a triangle is 180 degrees. What we have is angle A plus angle B plus angle C equal 180. So again, try to compute for angle C, which is nothing but angle C equal 180 minus the sum of the other two angles. So when you put the a plus b equal 180 into this, so what you get is angle C is equal to 180 minus 180. And as you can see, the angle C becomes 0. Well, this is not a valid case for angle C in a given triangle, right? So there are no triangle possible in this case too as well. So hope you are able to follow this. In the first case where the angle C has become negative, in this case too, the angle C is becoming 0. So both are invalid cases for a triangle. So let us see whether we get any valid case in other two cases. So quickly going to case number 3, where one angle is obtuse and the second angle is right angle, and third angle could be any other angle. So let us assume that angle A is obtuse, which is more than 90 degrees, and angle B is right angle, which is equal to 90 degrees. So when you do a sum of angle A and angle B, where equal to more than 90 plus 90, what do you get? Well, the answer would be more than 180 degrees, right? So again, going by the angle sum property of a triangle, and then when you uh, 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 look for angle C, which is nothing but 180 minus sum of A plus B. Now, when you put that sum of A plus B into this, well, again, what you see is that angle C is becoming a negative angle, because 180 minus more than 180 will result in a negative number. So there are no triangle possible with this negative C angle. So this case number 3 is also not possible. So coming to the last case number 4, so let us see how this looks like, where the two angles are acute and the third angle could be either obtuse, right angle or acute angle. So let us suppose the two angles A and B are acute angles. That means both are less than 90 degrees. Again, when you do the sum of A plus B here, so A is less than 90 as you have seen, and the B is also less than 90. What do you get? Well, there are actually three sub cases here. Well, one could be the sum could be less than 90. For example, if you take A and B as say 30 degrees and 45 degrees, 30 plus 45 is 75, that means which is less than 90. But at the same time, if A is 45 degrees and B is also 45 degrees, both are acute angles here. If you sum up 45 plus 45, it is 90. So this sub case is also possible. But again, if you take another example where angle A is 60 degrees and angle B is 60 degrees, when you sum up these two acute angles, you will get 120 degrees, which is more than 90. Obviously, in this case, it will be less than 180 degrees. So as you see, like in this case, there are three sub cases possible. Again, going back to the angle sum property of a triangle, where the sum of all the angles in a given triangle sum up to 180 degrees, and then when you start looking for what is the value of angle C, and then substitute these three sub cases into it, you get obviously three different values for angle C. In case 1, where angle C equal 180 minus less than 90. So when you subtract anything less than 90 from 180, what do you get? You get more than 90 for angle C, right? I mean, angle C in this case is an obtuse angle. Again, going the same lines, if you look at the sub case number 2 here, where A plus B equal to 90 degrees, then you get angle C is also equal to 90 degrees. That is, C is in this case a right angle. And that putting the third case as well here, where 180 minus more than 90, which is this angle C will be less than 90 degrees. So angle C will be an acute angle. But in all the cases, you see that a triangle is possible in all these things. So it proves that a triangle is possible only when at least two angles are acute angles. So hope you are following this. This is again, please pause and then try to look at all these sub cases and things would be very easy to understand. Hope you have enjoyed this video, and I'm going to see you in the next video. Thank you very much.